cell terminology. That is, cell terminology, there are some terms, that is EMF of a cell, internal resistance of a cell, terminal potential difference of a cell. First, let us talk about the electromotive force, EMF. That is, any device which can continuously supply energy to the flow of current in an electric circuit is called electromotive force. See, suppose there is a circuit with a resistor, and this is a positive potential, negative potential, positive side, negative side, higher potential. So current will flow from here to here. Since I is equal to charge in a given time, it means for the charge to flow, charge flowing in a given time is current. It means what? Any device which can continuously supply. So it means there should be some supply to push the charge from one place to another place. Then only there will be a flow of charge and flow of current. It means what? This is higher and this is lower potential. So this device which supplies, which continuously gives the energy for the flow of current is called EMF. So such devices transfers energy from non-electrical form to electrical form, because here how the energy is produced in a cell. In the cell, see, the energy can be produced from the battery. In the battery, the energy is produced from chemical energy to electrical energy. In generator, mechanical into electrical energy. And in nuclear reactor, electrical energy is produced by nuclear reaction. What is the mean by EMF? EMF means the term EMF. The term EMF represents the open circuit potential difference across a device terminal. What is open? Why we call it as open potential? See, suppose we got a cell here which has got EMF like this, and a circuit is connected and resistance is connected. This is positive, negative, and this is connected now. This is EMF, it has got a value of some energy. So this is positive side, negative side. When the current is flowing like this, there will be some voltage drop which is equal to current flowing in the circuit and R. It means what is the potential difference? Now it means E minus IR is the net voltage, because some power is lost here. From this something is lost. But if it is open, if this is open, so there exists a potential difference. This is negative side and positive side. If we measure the voltage between this one, it will show the EMF. Why? Because since current in this is equal to 0, it means no voltage drop occurs here. It means whatever the EMF, whatever the voltage available across this open circuit, open terminal is equal to EMF of the battery. So this represents, it means EMF, the term EMF represents the open circuit potential difference across the device terminals. Therefore, the potential difference across the potential difference across the terminal of a cell when it is not delivering current. It means when it is open, this is open, circuit is open, it does not deliver current, because for the current to flow in the circuit, it should be a closed path. Since it is a open area, so it is open, so no current will flow. Therefore, the potential difference across terminals of a cell, across the terminals of a cell. This is one terminal here, another terminal here, across the terminals of a cell, when it is not delivering any current, is called EMF of this cell. That is energy given by the cell in the flow of unit charge. That is energy given by the cell in the flow of unit charge in the whole circuit is called EMF. Energy given for the flow of current, for the flow of unit charge. Current means unit Current means charge in a given time. Therefore, that is the energy given by the cell in the form of unit charge in the whole circuit, that is including cell, is called EMF of the cell. Now, on what factors the EMF depends? EMF depends. Suppose EMF means there is a, we can call it as a cell, we can take a cell which has energy, that is which gives, so this is a cell, electrolyte in this. So this is anode, this is cathode, positive, negative. When we are collecting through the external resistance, external resistance, the EMF, this is called a cell. This produce EMF, which depends on nature of electrolyte and metal of the electrolytes. This is the electrolyte, and this is the metal, electrode metal. It means it depends on what? It depends upon the nature of the electrolyte and the metal of the electrodes, and it does not, the EMF, electromotive force of a cell, does not depends on area of the plates, distance between the electrodes, this distance between the electrodes, and the quantity of electrodes, how much electrodes we are filling here, either less or more. It does not depend upon the quality of electrodes and size of the cell. It may be smaller, it may be bigger, but the EMF does not depend upon the area of the plates of the conductor, that is electrodes, distance between the electrodes, quantity of electrolytes, and size of the cell. It depends only on the nature of electrolyte and metals of electrode. It does not depend on any other factor. It depends only on electrolyte and metal of electrodes. EMF of a cell for flow of charge and hence current. Since what is charge? Current is equal to charge divided by time. It means for the, suppose there is a resistor here and we connect a battery which is the source of EMF. It has got a EMF where this is equal to epsilon, which is EMF. It supplies the energy for the flow of charge. Suppose this is positive terminal, from positive terminal the current flows. Current flows means what? Charge is flowing. For flow of charge and hence current. For flow of current and hence charge. From the relation it is understood, charge flowing means current is flowing. So through this resistor, it should be at a higher potential. This is positive side and this is negative side. Current is flowing this way. There has to be, it means, because this is 20 volt means there is a potential difference between this point and this point is 20 volt. It means this point is 20 volt less than this point, or this point is 20 volt more than this point. This is positive side and negative side. There has to be a potential. This potential difference is applied here for the flow of current. For flow, so for flow of current through a resistor, there should be a potential difference across this resistor. So the current will flow as long as there is a potential difference. Current will flow through the resistor as long as there is a potential difference between its end. See here, we take a U-tube. When this is at this level, the liquid at this is at level, and it is by a tap. When we open the tap, the current water will flow from here. How long it will flow? When both the levels are equal, then the water will, the fluid, anything will go. It means there should be, see, water is flowing this way, water is flowing this way. It means this is at higher potential, this is at lower level, then only the liquid will flow. Same way, the current will flow as long as there is a potential difference exists between the two terminals. When the current will stop flowing, because when, see, now it is flowing from here to here. Now when both the levels are equal, it means both are having same potential. This and this are having same potential. Since this and this are having same level, no water will flow. It means whenever there is no potential difference between these two ends, no current will flow. There has to be a potential difference between the two ends, which is given by the battery. So the current will flow as long as there is a potential difference exists, and the current will not flow if there is if the potential difference becomes the potential difference between these two ends becomes equal. The flow of current stops. It means flow of charge from here to here is stops. So it means when it is stopping, what we will have to maintain the current flow. Current has to flow. What we have to maintain the steady flow of the charge and hence the current. To maintain the steady flow of charge and to maintain the potential difference. Because if the current has to flow, there has to be charge is to be flow, and there has to be a potential difference between these two terminals. If the potential difference between the two terminals equal, there will not be any flow of charge and hence current. Therefore, to maintain a steady flow of charge and to maintain steady flow of charge means steady flow of current, and there has to be a potential difference between the two ends. Therefore, to maintain the steady flow of charge and to maintain a potential difference between terminal of the resistor, we give a system, we give a device called cell or battery, which gives the energy so that the charge is flowing, which creates a potential, because this is positive side, negative side, which create a potential difference across the resistor. Therefore, there will be a flow of charge and hence current. So a device called EMF device, that is battery or cell, is needed. A device called EMF device, which is battery or cell, is needed. So we can say EMF of the battery. What is EMF of the battery? Already we told EMF of the battery is the work done per unit charge in moving. EMF of a battery is the work done per unit charge. EMF of the battery, that is EMF. It can be in this book also, it can be like this also. Epsilon is the work done in moving a unit charge. Work done in moving a unit charge from lower level to higher level. Because see, if you want to pump the water from the lower level to higher level, see, since both the potential difference is zero, it means no current will flow. Both the levels are equal, no water will flow. So it means we have to press this one so that it will rise up. It means some work has to be done. In a given time. Or here, EMF is defined as the EMF of a battery is the work done per unit charge. Work done per unit charge in moving a charge from lower to higher potential. To lower to higher potential, if we have to move, that means we have to do work. Why we have to do? Suppose we want to lift a bag from floor to up to this level, it means we have to do work. From higher level to lower level, if it has to go, then we need not do work. We just drop it, it will go. But from lower level to higher level, so that to create a potential difference, since both are at the same potential, so to create a potential difference, earlier both are at same potential, and to create a potential difference, some work has to be done, and the work per given time is called the EMF of the battery, where EMF is needed to create the potential difference and hence the flow of current or flow of charge. Therefore, EMF of a battery or a cell is the work done per unit charge. EMF of a cell is equal to work done per unit charge in moving a charge from lower to higher potential. See, suppose we have a battery or cell which is the source of EMF from lower to higher potential terminal. That is, if this is A, terminal A, this is terminal B. A terminal A, and so this we call it terminal B, terminal A. In the work done in moving, because from lower potential to higher potential, if the charge has to move, some work has to be done. From lower level to higher level, water has to be pumped, work has to be done. Same way, EMF of a battery cells is the work done per unit charge in moving from lower to higher potential terminal. That is from B to A. So it means we connect a resistor here, external, which is called external resistor R, and this is the EMF of the cell. This is positive side, negative side of this cell, which is the source of an EMF. So what you can say, where EMF open, throw a key, we connect it, throw the key. So what is work done? We keep this as open end, because if we are closing it, the EMF, some voltage will be dropped here, which is equal to I into R is the voltage drop here. But we are interested only the EMF, so that if it is open, no current will flow. If the no current is flow, so this is end, this end is here, and this end through this is here, and it is open, so that there is no connection here. So the term I is equal to 0. It means if we measure the voltage through a voltmeter, it will show only the EMF of the battery, and there won't be any drop here because current through is equal to 0, because it is open. So always we keep it as open to measure the EMF of a battery. What is EMF of a cell? See, E is equal to R, we can write it as this way, of a cell. EMF of a cell is equal to work done in bringing a unit charge from lower to higher terminal. That is, from lower terminal to higher terminal when the circuit is open. Let us prove it also. E is equal to EM of the cell, E is equal to work done by charge, or we can write work done divided by charge. What is work done? We know in physics we must have read work done is equal to force into distance. How much force we apply and how much distance that is moved divided by charge. That is the definition of work done by charge. So this is equal to EMF is equal to force into distance moved divided by charge. That is the EMF. What is, we have already studied in the electrostatics. What is force? See, force given on a unit test charge is equal to electric field. It means force is equal to charge into E. This already we have seen in electrostatics. F is equal to Q into E. So we can represent this one Q into E divided by into D divided by the charge. This get cancels. So electric field is equal to E into D. Now you have to remember electrostatic. You can't forget what we have already studied. What is E dot D? E dot D. See, electric field is equal to negative potential gradient. It means V, or we can say it V by L. That is, potential applied divided by distance is equal to electric field, or we can say electric field is equal to V by D, or V, or what is potential difference is equal to E into D, or we can write E into D. What is E into D? E into D is equal to potential difference. Electric field, it means EMF is equal to potential. So therefore the EMF of the cell, that is source, This is the source which gives the EMF. Therefore, the EMF of a cell is equal to what? Equal to the potential difference. Equal to the potential difference between its terminals. The potential difference between the terminals. See, here we can draw the circuit diagram. This is the EMF which has got this is a cell which has got a EMF. This is open. A circuit is flowing. So what is the potential difference across this one, which is equal to EMF of the cell when it is open? When it is closed, it is different story. Why? Because there will be a potential drop across this resistor. Therefore, when it is open, current through is equal to 0. The potential difference between these two terminals. This is one terminal, this is another terminal. So we can say, therefore, the EMF of a cell, that is source. EMF of the source, which is the source. This is the source which gives the EMF, is equal to the potential difference between its terminals in case of open circuit. In case of potential difference in case of when it is open, the current is equal to 0. I once again repeat, the EMF of a cell is equal to the potential difference between its terminals in case of open circuit, that is I is equal to 0.